Welcome to section 5.6. This is Mrs. Lewis. We're going to discuss reflections. In the previous section we discussed translations, and we talked about how a translation just means that, like, let's say you've got an object like this. A translation is just a slide. You just move it over, but you don't turn it, you don't rotate it, you don't do anything else, you don't shrink it, and you don't make it any bigger. It's exactly the same size, it just got slid or moved. So that was the translation from section 5.5. 5.6 is the reflection. So you should have a page that looks very much like this page, and you're going to be using that, just reading along with me. A reflection or flip is a transformation in which a figure is reflected in a line called the line of reflection. A reflection creates a mirror image of the original figure. And we have two examples. In the first one, the line of reflection is running this way, and then we can see that the red bicycle and the blue bicycle are mirror images of one another across that line of reflection. And you can also see how it creates that flip where the bottom one looks upside down. Over here we've got a vertical line of reflection, and you can see how the blue and the red are mirror images of one another across this vertical line. And you also see how the blue one has been flipped from the red one, so it's like it turned it around backwards. With a reflection, the original figure and its image have the same size and shape. Alright, so that's the concept. We're going to look at some examples. So we're going to look at your 5.6 practice sheet. And in the first one, we're asked to tell whether the shaded figure is a reflection of the non-shaded figure. So for number one, this is our line of reflection. So the idea, actually before we do this, I've got a couple of examples we'll look at first. So in my first example, my question, technical difficulty, there we go. Okay, so in my first example, I've got a line of reflection here. Are the triangles reflections of one another? So to answer that question, I've got this done on wax paper, which is really nice because I can see through it. If these are reflections of one another, then that means if I fold my paper along this line of reflection, it should look like one picture. So if I do that, I'm going to fold it along this line, and then when I press it down, you can see through the paper. You can only see one triangle, where you know that there's supposed to be two triangles. So this shows me that they are reflections of one another because they create that mirror image where they're sitting directly on top of one another. So that would be yes. The triangles are reflections of one another. Okay. In my second example, are these mirror images or are these reflections of one another? Okay, so here's the line of reflection. It's a horizontal line this time. Okay, so to answer that question, I'm going to fold my paper along that line of reflection, press the paper down, and watch what's happened. You do not see a single arrow, you see pieces of two different arrows. So because they're not lying directly on top of each other, then these are not reflections of one another. This would be no. Alright, now we'll look at these examples on our sheet. So in our first one, tell whether the shaded figure is a reflection of the non-shaded figure. So I've got some more wax paper that I'm going to use for this, and I don't even need that much. In number one, you see we have this line of reflection. So I'm just going to hold my paper over it, and I'm going to trace it. This is my line of reflection, and I'm going to trace my two pentagons. And you may not have to do this to see it, but if you do, it's okay. So tracing my two pentagons, and I'm going to extend this line of reflection out just a little bit to make it easier for myself to fold it. Okay, so I'm going to fold my paper along that line. Alright, and by doing that, this is what I've created. Okay, so you can still see two pieces of two separate polygons there. So the answer to that one is going to be no. They are not mirror images. In number 2, here's my line of reflection. If I do the same thing here, if I were to fold it along this line and bring these two together, would they be the same picture on top of each other? The answer to this one, if you need to pause the video and take a moment to think about it, that's fine. I'll give you a second. So the answer to number 2 is going to be yes. These are reflections of one another. If you bring these two pictures together along that line, they will sit directly on top of one another. For number 3, take a moment, pause the video if you need to. The answer to number 3 is yes. If you were to fold your paper along this horizontal line of reflection and bring the two shapes together, they do create a mirror image of one another. So they are reflections. Number 4, find the coordinates of the figure after reflecting in the x-axis. So make sure you remember where the x-axis is. This is the x-axis. It's the horizontal one this way. So we need to locate these 3 points. We need to order pair 1, 2. We need ordered pair 3, 3. And we need ordered pair 0, 4. And I should be labeling those. So 1, 2 was A. 3, 3 was B. 0, 4 was C. I can connect these to create a triangle. They want us to find the coordinates after reflecting in the x-axis. So if I reflect in the x-axis, that means it's going to be coming. This is my line, my line of reflection is this line here. So this point A needs to come down. It was 2 spots or 2 spaces above the x-axis, so the mirror image will be 2 spaces below the x-axis. It's going to be right there. Point C was 4 spaces above, so it needs to go 4 spaces below. So that puts it there. And then point B was 3 spaces above, so we want to bring it 3 spaces below. And here we have our new figure. This is what we call the image. The image is the result after the transformation has occurred. And they want us to find the coordinates, so we need to list these coordinates. And when we do this, we can use the notation, the corresponding point on the image to point A, which is going to be this one. We can call it A prime, like this. It just has a little mark next to it like that. So that just means that that's the corresponding point to point A from the original. So the image of point A is ordered pair 1, negative 2. The image of point B is this one, and that's ordered pair 3 on X, negative 3 on Y. So we'll say image of B is ordered pair 3, comma, negative 3. Our original point C was at 0, 4. Alright, our C prime, or our image, is down here at negative 4. So C prime is equal to order pair 0, comma, negative 4. Okay, so that's how number 4 works. So I would like for you to pause the video. I'd like for you to do number 5 and then come back and see how you did. So the answer to number 5, the image of point W would have been at ordered pair 4, negative 2. X, the image of X is at 3, negative 4. The image of Y is at 1, negative 3. The image of Z is at 3, negative 1. So you can see the reflection right here. That's where those coordinates came from. In number 6, find the coordinates of the figure after reflecting in the Y-axis. So the difference here is that now you're going to reflect it across the vertical line. So let's locate these points. We have point J is at ordered pair 3, 4. Point K is at ordered pair 4, 0. And point L is at ordered pair 2, 3. Okay, so we'll connect these, forming a triangle. We're going to reflect in the y-axis, so we're going to bring everything to the other side of the y-axis this time. So point L is the closest to the y-axis, so if I start with it, point L was originally at ordered pair 2, 3, so it needs to come back over here. Alright, and its coordinates are going to be negative 2, 3. So that's the image of L is at 2, 3. I'm sorry, negative 2, 3. Point K was at ordered pair 4, 0, so its image across the y-axis will be way back here at negative 4, 0. And that one is K, the image of K, negative 4, 0. Alright, and finally, point J was originally at 3, 4. Its image will come over here to negative 3, 4. So we can say that J prime, or the image of J, is ordered pair negative 3, 4. And we'll connect those dots. Okay, and you can see that reflection across that y-axis that's formed by that. Okay, so you can try number 7. Number 7 is going to work like number 6, only it had 4 points instead of 3 points. So pause the video and complete that one, and then check your answer. Okay, for number 7, this is the original figure. The image is going to be over here in quadrant 2. You can see that they form a mirror image or a reflection of one another across the line, across the y-axis. The coordinates of these points over here, the image of point M would be negative 2, 2. The image of point N is negative 2, 3. The image of point P is negative 3, 3. The image of point Q is order pair negative 4, 1. So those should be the answers you got to number 7. If you don't understand something, make sure that you ask somebody for some help. Alright, and then let's look at number 8 together. Now this is talking about a pinball game, and I don't know if you guys know anything about pinball games or not, because they were very popular a long time before you guys were born. But maybe you've seen it in a video game. But the idea, let me zoom this in a little bit. Alright, so the idea is that with a pinball game, the ball is going to shoot out, and then it wants to fall down, and there's a little hole down here. There's two little I don't know what these things are called, levers or something, but they bounce the ball back up. So you keep bouncing the ball back up to keep it from falling in the hole. So that's the way the pinball machine works. So in this question it says, in a pinball game, if you perfectly reflect the ball off of the wall, and they're telling us that this is our wall, right on the y-axis. If you perfectly reflect the ball off of the wall, will the ball hit the bonus target, which is located there? Okay, so what does that mean? They're showing us that if I flick this thing and make it go back up, okay, they're showing me that the ball is going to follow this dotted line. They want to know what happens if it continues to follow the mirror image, so it's bouncing it off the wall and it comes over this way. Is it going to hit that target or not? So how do we figure that out? Well, let's look at where the ball is now. Okay, and then if it follows this path and then it follows this path over here, that's going to put it somewhere up here. How do we figure out exactly? Well, you just need a mirror image. You need a reflection of the ordered pair from down here. What is that ordered pair? I can see that's at x equal 2 and y equal 4. So I need the image of ordered pair 2, 4. So I can get that if I go up 1, 2, 3, 4. Puts me at 2, negative 4. So it's right there. I'm sorry, I think I said that wrong. The original ball was sitting over here at ordered pair 2, -4. We want the image of this is going to be this point up here, and that point is ordered pair 2, +4. Okay, so if the ball follows this trajectory to that point for the image, has it hit that target? Well, it's actually gone above it. It did not actually hit the target. It went over it, so it would be no. Okay, so again, just ask if you're not understanding something. I'll be happy to explain it some more. Or maybe your classmates understood it. All right, so the next thing that you'll do after you complete these notes, you'll be doing 5.6 practice A, which is in your binder. So that's going to be the next place to go from here. All right, thank you, and that is the lesson for section 5.6. So we'll work on these some more together in class.